Well, hi, everybody. It's meteorologist Joe Cioffi.
And meteorologist, excuse me, forgot to clear my throat.
Please.
Joe Rao.
And you're watching right now a live cam from Syracuse, from the Armory cam, where they're getting the lake effect snows. Looks like they had enough, Joe, to whiten the ground a little bit earlier. A few folks walking around. Not a whole lot of snow there, but this is all part of that lake effect machine that has gotten underway with the storm that's intensifying in eastern Maine. Very much the driver of the weather pattern going forward. And of course tonight, speaking of weather patterns and going forward into the future weather-wise, we promised last night, and he has joined us. Dr. Judah Cohen is back on. Thank you so much for coming on tonight on our live stream. And we're all excited to hear your thoughts about all that's happened with this the split of the polar vortex in the stratosphere.
It's a pleasure to be here. Thanks for having me on.
You back when we had you on back in October, and we talked about this. If maybe you could kind of just quickly recap, what was it that you saw going into the fall and winter months, in the early part of the winter months? What did you see that kind of hinted that something like this could happen?
Yeah, I mean, the snow cover got off to so the thing I look at first is the Siberian snow cover got off to a slow start, but it had a very fast finish. And so one of the indicators developed is like this, the rate of advance. And so if it's a slow start and a fast finish, that kind of, so that's kind of the most accelerated rate, right? The trend is most positive when that happens. So it happened kind of late. I mean, the indicator itself was kind of neutral, but if I think of it like in the spirit of things, it seemed like it was certainly an indication. So when that's positive, this rate of advance of snow cover across Siberia in October, that's an indication of maybe, I've come to interpret it anyway, that there might be a polar vortex disruption earlier in the season. Last year, the value was negative. I thought if we're going to get a polar vortex disruption, it would be later in the season. And also, there was low sea ice, and I thought that the low sea ice would be focused in the Barents-Kara Sea region. That's near Scandinavia. And the research is showing that low sea ice in that area is most favorable also for disrupting the polar vortex. So I think, this winter we had in tandem both that rapid advance in the snow cover at the end of the month of October, and we had the low sea ice in the Barents-Kara Seas, and that's happened all fall. And I thought, that would be favorable, for disrupting the polar vortex. One thing I thought, if we were going to get a polar vortex, it might be better. It might be easier to get it in the early part of this season because the QBO, the quasi-biennial oscillation, was switching from easterly to westerly, or was predicted to do so this winter.
And when you talk about a term like that, you're talking about these sort of long-term shifts in weather patterns that are measured not just in days, but really,
right,
they go
so
long term.
It's called biennial oscillation because it oscillates every 2 years, it goes through its full cycle every 2 years. So 1 year it tends to be easterly, the next year tends to be westerly. Last year was easterly, this year it's changed to westerly, but it measures the speed of the wind over the tropics in the stratosphere. Anyway, but regardless, so we've had now these two polar vortex splits or disruptions, significant ones, two winters in a row. And I did tweet this out, but I like to point out we had different phases of El Nino. Last year was La Nina, this year is El Nino. We had two different phases of QBO, that quasi-biennial oscillation, and we also had with the Mann-Julian oscillation, which again is an index of convection in the tropical Pacific. That was also in a different phase, between the two different, polar vortex splits. The only thing that I can find that's really been consistent or constant between the 2 years has been the low sea ice in the Barents-Kara Sea and the an extensive snow cover. So I'm kind of talking about two different indices for snow cover, but snow cover was above normal in October across Siberia this October and last year as well.
Yeah. Okay. So just let me know when you want me to bring up your PowerPoints. I want to. We have our European.
Well, we're talking about the polar vortex split. If you want to bring up the first slide.
On the PowerPoint. All right.
Yeah, the very first slide shows.
All right. So give me 1 second. I'm going to bring it up on the screen. And there you have it. So bring it up front and center here. Okay, so the PowerPoint is up, and we can see that we're looking now at the stratosphere. So we're way up. We're talking 6.5, 7 miles up, and
more than that. It's like 20 to 30 kilometers. I mean, at least 15 miles up, I think. But
okay. But it starts when you go through the tropopause, and then we go up in the stratosphere where this is not an area that the average forecaster every day really pays attention to.
No, definitely not.
Okay, so go ahead and we could see on here you've got the four these four.
So four panels. The first one is what today is initialized or analyzed. This is what the current situation from this morning. Okay?
Right.
So it's the 0Z model run.
January 9th.
That's the top of that panel. What's
correct.
That?
Yeah, it's the top left. Go ahead.
Yeah. So you can see. So there's. I don't have highs and lows in here, but that high center that's kind of north of Alaska, it's in the Beaufort Sea, but extending over to the North Pole. That's high pressure, and then you can see it's kind of in the red shading, which means it's above normal temperatures. That's so normally there's a polar vortex, there's low pressure, cold low pressure sitting right over the pole. So we've had a disruption. It's off the pole. It's got a high pressure set, and the polar vortex itself is split into actually 2 or 3 pieces that you can see at this point. One is very close to Scandinavia. And the other one is sitting over eastern Canada and New England, a little bit more elongated there. So those are the 2 main vortices. There seems to be a third one there out over the Pacific. So, and I like to use a rule of thumb where the polar vortex goes, so goes the cold air. It hasn't been terribly cold across the U.S., but I'd say the little cold air there has been focused there in eastern Canada, into the northeast, and it's been also quite cold in southeastern Europe, at least. I know it's gotten into Central Europe. I certainly have been hearing a lot of tons of snow there in the Alps, but also in Turkey, seen some just incredible videos.
Even on the beaches of Italy.
Italy, I think I made
Italy, Sicily.
I saw pictures of Sicily, Greece also, I think.
Yes.
So, I mean, unusually cold and snowy down there, down to the Mediterranean, in the southeastern part of Europe.
Dr. Cohen, I don't want
the Middle East. What's that?
I didn't want to interrupt you, but because of the fractured nature of the upper level stratospheric wind flow, we've been analyzing this over the last few days, actually last couple of weeks, and we've been telling our viewers that in such a situation like this, the main word here is time. And we've been saying that the cold is eventually going to get here, but it's not going to come all at once, and it actually is going to be coming more in stages.
Right.
And I was wondering if you would agree with that.
Yeah, absolutely. So that's in the second slide. I could talk to that.
Okay, second slide coming up.
Okay, but before
okay.
Let's stay on this slide before we move on.
All right, back to the first slide.
I think to take from the 10 millibar charts is that you can see that there's 2 vortices, maybe it splits into 3 at times, but they stay split for the whole 2 weeks, and it's a very long-lived event. I mean, it's not. I don't think it's normally. I have a little toy polar vortex model. It really doesn't say it's going to recover till about beginning of February. So it's really an unusually long-lived event with the 2 pieces. The one in North America kind of slides a little bit further west. I think that might actually. I don't want to read every detail and
right. In the broad sense.
Well, I think it maybe at least it's to me it suggested that I think it might become more conducive for cold air, especially and backing it up further west. Because like I said, right now the cold air is kind of been limited to the far eastern part of the continent. I know Labrador is also not a place that's going to get news for, Newfoundland, Labrador, not a place that's going to make the news for having snow, but they've had a tremendous amount of snow there as well. And then the other, so I do think that at least, even if it's not terribly conducive for cold now, I think it might become more conducive for colder temperatures. Just in general, so there are two types of polar vortex disruptions. There's the displacement where the polar vortex stays, the integrity remains. It stays one piece, but it's just displaced. It's knocked off the pole. And then we have these polar vortex splits, which is the one we had we had the one last year as well. Actually, I think all the polar vortex the large polar vortex have all been split since at least 2008. So I don't know if that's a trend that'll continue, but there's something of interest there. But
so you said basically that in the short term of things, what we're talking about, as I just mentioned a few moments ago, is that we'll be seeing more of a surge of more surges of colder air toward the end of January. But you think more like February would be the month then?
Yeah. Well, let me just give me one more minute and we'll move on. But I do think polar vortex strips are maybe more memorable for their snowstorms than their cold. So we'll see if that happens. But you have to give it time, like we're going to say in a second. But also looking at Europe. We get cold air, we get it from the north, but actually they get their cold air when it comes in from the east.
Right.
And if you look at the polar vortex, the way that second lobe that we call daughter vortex, that if you follow the counterclockwise flow around it, it's a long duration easterly flow towards Europe. So if that type of pattern would translate its way all the way down to the surface, I mean that could be a long stretch of cold weather there in Europe, but
and that is the key, is it not? It needs to translate down to the bottom of the atmosphere.
Okay, you guys keep. So let's move on to the next. Slide.
All right, no worries.
So the deeper red shading at the top of the. So I'm looking at the left plot, and the deeper shading there. On the top of the plot. So that's the stratosphere. You get that. So that deep red shading. That's the kind of this polar vortex disruption. You see that. If it was a normal vortex, we would see blues up there. Because it was cold. But it's the red. This long duration of red really shows you've got this prolonged polar vortex disruption event. But it stops at about 150, 200 millibars. That's a tropopause. So it's really been so far a stratospheric event, nothing really doing in the tropopause. There's a little bit of this plot, a different version of it. This is geopotential polar cap hype anomalies that are being plotted here. But another version of it, the northern annular mode, which is the AO, it's been called the dripping paint plot. Because it kind of just drips down from the stratosphere into the troposphere. You get kind of the sense of that even in this plot. So you can see there's one of these drips is going to happen around this weekend, and it seems to be timing with this East Coast snowstorm that we're predicted to have. Really, I guess it seems to be favored in the Mid-Atlantic. But then you see more dripping happening, later towards like the Martin Luther King weekend. And that one looks, deeper red, at least this predictions from the GFS. So, that might be more intense, certainly more intense cold. So we'll see. But we would expect to see kind of these spokes or these like drips. And certainly this event coming up later in the week really looks like it dripped right out of the stratosphere. So that's what, So I guess I could have sent you, this plot for, like a previous winter where we had a polar vortex split, like 2012-13.
Right.
And you can see how you get this dripping from time to time, and coinciding with each of these drips, I like to call them pulses because the Arctic pulsates warm. That's where you really tend to get your severe winter weather events, whether they're cold air outbreaks or snowstorms. So this one looks pretty mild, but I expect them to become more intense as the winter goes on. So this first one is pretty, not, there's nothing terribly exceptional about it, but might be just enough to kick off the snowstorm. But then, because you want the red shading means, that's the deeper the red, the warmer the Arctic is. And I had a paper actually just came out last year showing that severe winter weather really has a very strong, nice linear relationship with Arctic temperatures. When it's cold in the Arctic, you don't really get so much severe winter weather in the Northeast U.S. And this really, I think, is also, it's kind of true for other parts of the globe, including Europe. So when it's cold in the Arctic, you don't get severe winter weather. And the warmer it gets, especially when the Arctic is extremely warm, you get the highest probability of getting severe winter weather.
Well, we have here in the New York City, excuse me, here in the New York City area, Dr. Cohen, we actually had an unusual out-of-season major snowfall. I don't know if you're aware of it, back on the 15th of November. And today marked the 55th day at Central Park where we have had hardly anything aside from maybe just some flurries in the air. Now, as you just alluded to about a minute or two ago, the Mid-Atlantic may be seeing a significant snowfall this weekend. And yet, for all the snow lovers here in the New York metropolitan area, those who want to see some snow, that cold air that you alluded to in Labrador and Newfoundland and eastern Canada may be maybe not dripping, but oozing on down. It's a very dry, cold air mass, and that may actually serve to shunt or suppress that storm from reaching us. It may hit Virginia or Delaware or even down in the Carolinas, but it may actually serve to work against the snow lovers here in the New York area. It'll get cold, and obviously a very dry cold, but it may actually serve to keep much of that snow that some of those snow lovers have been waiting for out and to our south, and keeping them very unhappy.
Well, let me also add this, because one of our regulars that's watching tonight, Scott Briller, referenced a tweet that you that you made today, and it was in relation to snowstorms during the polar vortex split, and this is I guess the first one, and I had one of my other regulars, Timothy Veltman, asked a similar question. Can we look for the pattern to evolve the way it has evolved so far, to continue?
Yeah, so I sent out a tweet. I mean, it's been my observation. I haven't really done research on this. That it's not like I said, it's the PV splits I don't think are kind of equal opportunity snowfall creator. It doesn't snow everywhere, but it seems to be this repetitive. You get the storm track repeats itself over and over, the same storm track. So you get to kind of, it piles up. So you have winners and losers, or depending on your perspective. But I assume most of your watchers are rooting for the snow.
Well, certainly the snow lovers are, and I think the vast majority of the folks that are on my channel are definitely snow lovers. Particularly the folks in Europe. And I want to ask you a question. When we had the slide up with the 10 millibar, you had the split vortices in one in southern Europe, the other one was more towards Siberia, but they looked like there was one of the height lines, of course, kind of encompassed both of them. So it looks like they were coupled. And my question is, the vortex that's in North America seems uncoupled. Now, is there any importance to that coupling? What do you
mean uncoupled? You mean coupled to the surface?
No. It looked like they were coupled together. You had the main vortex in Siberia, and then one of the height lines kind of extended around, and you've got that second vortex that looked like it was down close to Spain. So I've seen a couple of people look at that and say they look coupled. Is that just because it just kind of shows up that way on the map? Is there any kind of significance to the kind of weather that would be produced by having that vortex sort of stretched out the way it looks on the map?
Yes, I think for Europe, it's the direction of the flow that's most important. I mean, the thing that I take away is just a long easterly fetch across the whole Eurasian continent. So, that's the thing that to me is striking, and I think that portends, possibly, this cold weather coming out of Siberia, into Europe. So that's what I take away. That's the thing that catches my eye is just that easterly fetch. I don't know, the vortex itself, it's in one and two pieces at times. It's moving around, but the one thing that seems to stay constant is this easterly fetch.
All right, so go ahead. I'm sorry. Finish. You go ahead.
So that's the thing that I think that I focus on. Again, I don't have much. Right? It's not like I've done research and I can say every time in the polar vortex you got this easterly flow, you turn super cold in Europe. It does remind me of last year, and I was calling for cold weather in Europe. It was based on that easterly flow in the stratosphere, and it worked out. Again, maybe get everybody. You set the standard really high, for a bigger fall, but it seems to be something similar, in the stratosphere this year. So we have to give it time. These things take, on average, 2 weeks really to start making its way down. Like I said, this weekend is really the only first kind of drip, and it looks to me relatively a minor one, with more significant impacts coming, later in the month.
Well, judging,
I would expect it to peak in February.
Right. Judging from the last number of runs of the GFS in the long range, anyway, it seems to me that is the case. That the runs are getting colder and colder. The flow from Canada seems to be getting stronger and stronger. I brought up on the screen your next graphic, the 11 to 15 day temperature.
This is from the GFS. For this morning, so you can see it's cold in Europe, but it's cold also in Canada and getting into the northeastern U.S. That's where the large, at least based on the GFS forecast, the largest temperature departures, negative temperature departures are in Canada. And it looks really poised to come down into the eastern half of the U.S. So that's the GFS. I don't have as good access to European. It seems to me the European was slower in getting the cold air in here, but setting up this cold pattern, but I think it's on its way as well.
I've always thought, Dr. Cohen, just from the standpoint that cold air is, of course, a lot denser than warm air, and you've got all of that cold air, as you can see on this map, the top map, the 11 to 15 day T2M anomaly map. All that cold air, it's over northern and central and eastern Canada. Eventually, I would think that it's just going to have to spill southward. It may not happen, let's say, in the time frame here, the 20th to the 24th of January, and maybe not even at the end of January. But I think that eventually, by February, it's just going to get so cold and so heavy up there that it's just going to have to literally roll over the side of the Earth, down through the central and eastern part of the continent, and into our part of the country. And I think we're going to be due for a really maybe not, I don't know, prolonged shot, but certainly a very significant shot of very, very cold air, much colder than what we've experienced now. And again, we go back to the fracturing of the polar. We had like 2 or 3 different polar vortexes. So eventually, I think the climax, if you will, is going to come in February with a real good shot of cold air, not just confined to Canada, but for much of Central and Eastern North America. What do you think about that?
No, I completely agree with you. That much cold air, if the GFS is anywhere near right, and that much cold air builds up in Canada, I expect it to come south, with time. So I think it's really setting. We haven't had a real good February since, I guess, 2015. So it seems like, maybe overdue for one. But I think the setup is going to be very good for that.
These last few Februarys have been really weird. A couple of years ago, we actually had record high temperatures here in the New York area, and we followed it up 24 hours later with a near blizzard. So it's been really crazy in February these last couple of 3 years. And you're right, we are due for a good old-fashioned February, and maybe this is going to finally be the year for that to happen.
By the way,
it seems like all the pieces are in place.
Just so you know, a number of the folks watching have gone on the chat board here, and they're professing their snow loving. Jess Harden, Shelly Man Studios, Jason Schaefer, Cullen regards himself as a snow weenie supreme. So they're glued to your every word here. And on the Gef's, I noticed on the Gef's 11:15 24-hour snow change, it looks like at least for, and it's kind of a tight view there in North America, but it does look like it's northern Mid-Atlantic, Northeast, and Boston needs to get out. I think it's 260 days almost. It hasn't since the last time they saw an inch of snow. That's a long stretch.
These are the same people.
When New York got its snow, and I think it's November 15th. I mean, the whole Boston area got like 6 to 9 inches. I mean, I don't know, Logan reported I think 0.1 inch. It seems really strange, but yeah, it's been we haven't had. I mean, I guess you guys snowed in April. I don't know if we really got that snow in April. So it's we obviously got a lot of snow in March.
Yeah.
But it seems like it's been a while.
Boston, people forget. I don't know if they forgot or not, but I mean, was it 2-3 years ago they set the all-time record for snow in Boston at something like 105 inches, and now the same people are crying because they haven't had any snow of significance in over 200 days. It's amazing how they've gone from one end of the spectrum to the other.
Well, yeah, I don't know. Yeah, so again, it's probably different set of people, but there's all kinds. I mean, people. I mean, I'm surprised people complain when it snows here in Boston. I mean, it snows in Boston.
It snows in Boston, exactly.
Yeah, I mean, so it seems kind of strange to think otherwise. To expect otherwise.
I've got your fourth slide up, by the way. Now the 250 millibar wind. Was it the wind anomaly? Going back to some prior years in history.
Yeah, so I guess there's been some discussion. I've seen people discussing about the strength of the polar North Pacific jet. That that the North Pacific jet is just too strong to allow any cold air to build up and to come down here. I mean, I don't think the strength of the North Pacific jet is really the issue. I mean, the point of this slide was to look at different years. So it's an El Nino year, so that kind of a really canonical, classical one to look at is 97, 98. Let me pull it up. And so that's on the top left. You can see, so the contours are the absolute values of the jet. There's a jet wind, zonal wind at 250 millibars. If you look in the North Pacific, so you can see the jet core coming off of East Asia. You can see the shading is the anomalies, and so it really extends to the east towards North America. It kind of is directed towards California. The jet streak or the increase in the jet jet level winds. So that's maybe what I might expect from this year. That was a mild winter, relatively mild winter in the eastern U.S. Then here's another El Nino winter to top right. Again, you see that extension of the jet towards California, across the whole southern U.S. So I mean, it seems to me a strong North Pacific jet. But the big difference here is the North Atlantic. You really get that really nice North Atlantic, negative NAO signature with a strengthening of the, on the south flank of the jet and the weakening on the north flank of the jet. Then on the bottom left is a La Nina winter, is kind of just shows something a little different. So the jet really, as you get to North America, it really strengthens on the north side of the jet, it extends into the Pacific Northwest. It's not directed at California, and that was also cold in the eastern U.S. But you can see what has similar with the previous year, which was El Nino year, is that really classic negative NAO signature in the jet, with again strengthening on the south side, but strengthening on the south side, weakening on the north side. And then finally, here's on the past few weeks on the bottom right, so you can see it looks very much more like La Nina, because you're getting in the North Pacific, you get the strong jet again. It's strengthening on the north side, which is more La Nina, El Nino south side. So even though it's El Nino, it's behaving like a La Nina, at least the circulation is. It's pointed at the Pacific Northwest, again, more consistent with La Nina, but there's no NAO signature, negative NAO signature whatsoever. And in fact, maybe, there's this strong, weirdly kind of increasing of the zonal winds up there near Greenland over towards Siberia. So again, that's just not, you have a strong westerly flow in the Arctic. You're just not going to get any of that cold air being able to come down. There isn't that negative NEO signature. And I think if that changes and the NEO flips, goes negative, you lose that jet in the Arctic, which is really kind of bizarre. The strengthening of the westerly winds. I mean, I think regardless of what the North Pacific jet does, I mean, I do think. Obviously, you want to see that ridge. I mean, you don't want to, but I don't think it's a giant killer. I don't know what the right word, but it's not going to preclude any chance of getting cold air with a strong jet. With plenty of winters, we've had cold winters with a strong North Pacific jet. Actually, the North Pacific jet doesn't vary that much. It's the North Atlantic jet that really is the one that varies much more. The North Pacific jet is pretty constant or consistent from year to year, from winter to winter.
Just a couple of quick questions here. Quick questions and quick answers from you from some of the viewers tonight. Jess Harden, who's in Alabama. So he wants this polar vortex, this whole thing, to at least get one good solid shot of cold air to come down far enough south. And I mean, I know obviously we can't say, yeah, it's going to happen on such and such a date, but is this a pattern that would be conducive for colder air to head pretty far south into the southeast? One of these shots along the way, could it materialize in a pattern like this? And
I think absolutely. We have to give it time.
And we had one other person asking about he actually just moved to the Pacific Northwest and is a new viewer, and I lost his name, so my apologies for that. But he is now up in the Pacific Northwest, and he's wondering, what's the impact there? What's the general impact in the West?
Yeah, I mean, again, if we really get this warming of the Arctic, like I expect, and I think we would get, if the circulation anomalies from the stratosphere make it down to the surface in a real significant way, I would expect a warming of the Arctic. I think that favors, maybe a warmer, drier pattern for the Pacific Northwest, a kind of this West Coast ridge, positive PNA type pattern. So, I mean, that's what I would expect.
Okay. You want to do a little shorter range forecasting? Join us.
I also sent you, if you want, I sent you like that polar cap height from 2012-13 in your email. Because there you can see the whole winter. I just wanted you could see how you get this dripping. Again, we had the stratospheric warming.
I'm trying to find. This was the.
I just sent you it now.
Oh, you just sent it now? Okay, give me 1 second. I will.
If you can open up,
Absolutely.
While you're
it's from a
searching,
paper. But
you alluded to about 5 or 10 minutes ago about the Martin Luther King 3-day holiday weekend, and I have a special interest in that, Doctor, because there's going to be a total eclipse of the moon on Sunday night, the 20th, during that weekend, and so I've already started looking long range, trying to see what might or might not happen. And what strikes me is that there's seemingly, at least on the GFS, there's a very strong, maybe the strongest frontal cold front that we've seen yet this winter, apparently, that's getting ready to cross through here during that weekend with some nice cold air coming in behind it. Is that what you were alluding to earlier about the next possible really good shot of cold air coming in during the course of that weekend?
Yeah, I mean, I just think it's I don't know what form it's going to take. I just when you get those pulsating red, which is on that plot that we looked at, kind of says the next one's coming around that Martin Luther King weekend. It could be either snow or cold. I mean, but it tends to be severe winter weather. I don't know. I haven't really, I'm not looking at the details that far out. The models. I'm focused on this weekend storm first.
Yeah.
And
the only reason I'm looking ahead of that, I'm trying to determine if it's going to be clear so we can see the moon the night of the eclipse. But it does look like a nice shot of cold air coming in behind it, either during that Saturday or Sunday or Martin Luther King Day Monday. And as we said at the very onset of our conversation here, seemingly we're going to get our cold air, but it's going to come in progressions or shots or stages, and it looks like that next really significant stage is going to come again during that 3-day federal holiday.
I think that's a time frame to look for again. More wintry weather, whether it be an Arctic outbreak or a snowstorm. I don't know, but that's the period I would key on as the next one for something interesting. Winter weather wise. But
by the way, I haven't received. Did you just send that email?
I just sent it, like
Okay.
a minute or two ago.
All right, I'm checking here on my email, and it's hasn't loaded yet. So, was it a big file?
Not terribly big, no.
Okay, we'll give.
There's a graphic in there, winter 2012.
All right, so you know what? We'll give it a minute or two. Let me come back to. Let me bring you back up on the screen here, and.
Oh wait, I might have sent it to myself. So let me.
Okay. I want to talk about we've been watching the upper air and the developments that have been going on in Europe for the last few weeks. And one of the things that I've noticed is there's been this big, very strong upper high that has been sitting over England and Ireland, or just to the west of England and Ireland, and it seems as if, well, it has driven the mean trough position more towards Central Europe, and these troughs have really digged way south down into the Mediterranean. So we've had this kind of focus on winter weather with a lot of snow. You mentioned that at the beginning. We've been talking about that here. But one of the things that I've noticed is that in the last number of runs, that big upper high finally breaks down in another week or within the next week or so, and you start to see a gradual shifting of that trough position further west, more toward Western Europe and toward England and Ireland. Is this? I'm guessing this is part of that. Let's call it that bleeding or dripping process of the whole split in the vortex. Where now we're starting to see, the impacts at the bottom of the atmosphere where we are. You break this block down, so that allows, the trough winds up starting to shift west. You start to get these colder intrusions pushing from east to west. I'm looking at this correctly?
Yeah. So that high pressure was in November, December, was sitting over Scandinavia. That's where it was positioned, and I think that was critical for the.
I'm going to bring that up on the screen.
You got the plot? Is that what you're saying?
No, I'm going to bring up a screen, the 500 millibar for the European of Europe, and then I'll check to see if the email is in the meantime. But go ahead. Sorry to interrupt.
Yeah, so it was sitting over November, December for actually again a pretty prolonged period. But that was critical. That high sitting over Scandinavia, that region, was critical, I think, for really triggering this polar vortex split. And that's where my research, others have shown that prior to a polar vortex split, you kind of get that high pressure over Scandinavia. Post the polar vortex disruption, it tends to migrate its way over towards Greenland. And I think that's what we're seeing. So it's kind of in transition over there. It's made its way, just west of England. But I would expect that to keep going west towards Greenland. And then if it sets up around Greenland, that's a favorable position for, driving the cold air all the way, even into the United Kingdom. So that's what I would expect. Some of the models seem to have that high pressure kind of staying south.
But then it falls apart. I'm just looking at the latest GFS by 120 hours. Yeah, the upper high kind of drifts southward towards Spain and Portugal, and then it just starts to open up, and the ridge begins to shift eastward, and you start getting these troughs coming in from off the Atlantic, and also, but they seem to be coming down more from the northwest, and dropping southeastward.
The pivot point seems to be over Scandinavia and Norway, and as Joe mentioned, they seem to be like spinning around from the north and northwest into Central and Western Europe.
Right. Regardless of what the GFS is showing tonight, I would expect over time, that high pressure to drift to the west towards Greenland, allowing for the cold air to get dragged further and further west. toward, into Western Europe. And, as that plot that we looked at earlier showed, it was obviously the most dramatic cold was in Canada, but it was also cold in Western Europe as well. So that would be my, expectation. Maybe, if we get kind of that classic NAO in the end, maybe for February, then, cold Northern Europe, milder towards Southern Europe, the Mediterranean. But
by the way, I did get your graphic, and I have it up on the screen right now.
yeah. So so this is the polar vortex disruption, the last one that really really significant one. There was also in 2014-15, but not of the magnitude or amplitude of this year or in 2012-13. But again, you can look at the polar cap heights. You saw there was this stratosphere warming in the early January like it was this year, and then it kind of just drips down, and you get these pulsating with time, throughout the rest of the winter. This goes to March 31st. And but when you get these pulses, you get these kind of, the pulsing warm in the troposphere, which is important.
Even
you get these severe winter weather events. Maybe in the Northeast, kind of the big blow was the blizzard in 2013 in early February. I think it was February 6th. I think it was called Nemo by the Weather Channel. So that was I know at least at that storm here in Boston, the governor Patrick Deval, closed all travel on the highways for that storm. But
I believe that storm was the one that gave 34 inches in front of Joe's house.
Yes.
On Long Island.
I have never, I never thought I'd live to see the day to see 2 feet, and I did. And on Long Island, which, we kid around and say that Long Island is the new Buffalo, because I'm in central Long Island.
Long Island has gotten a lot of snow recently. I don't know
yes.
why.
Well, our average on Long Island is running the long-term average. I use Brookhaven Labs number because I think it's a bit more representative of the weird climatology that's out there that nobody really knew was out there until the Weather Service moved to Brookhaven and figured it out. But the long-term average going back to 1946 or 7 is about 31 3/4 inches, and the average in the last 18 winters is somewhere around 44, 45. And yeah, I think I've lived where I've lived for the last 30 some odd years. I've seen more 20-inch snowstorms in the last 16, 17 years than I saw in the prior 13 or 14 years. It's night and day what's been going on there. But you're right, I got 30 from Nemo. I think that was the first time I ever saw it snow 5 inches an hour, and I got to see it for about 4 hours, and it was like living in a snow globe.
Yeah, no, I was incredible. Yeah, it wasn't even predicted to, we were supposed to get a lot in eastern Massachusetts. We did, but you guys were the surprise. Up into Connecticut, it was that 30 plus to 3 feet.
Yeah, so when you look at that map, I'm in the middle of that one of those stripes. It was quite an experience.
Yeah, so, but I'm saying, but you every time you get these drips, that's when you get and it's not limited to the United States. This is Europe and Asia as well. But when you get that pulsating red in these polar cap heights, or would be the the NAM index. I like to use the polar cap height instead, but that's when to look for the severe weather. But it's not constant. It's not. It's you get this dripping. And so that's I would expect something similar.
We've had
really the most impressive pulsating warm didn't come until March that year. So I don't know. We'll see if we get that earlier this year or not.
All right. Well, that leads me to my next question, and this has been tossed around, and it seems as if the winters in general. It's not always the case. It wasn't the case really last year, but. They seem to be the falls tend to be starting later, the winters tend to be starting later, and they've been extending themselves through March and into early April. So my question is, if we're seeing this split now, and judging by how long you think it will have its impact, are we destined for another stretch where winter extends into March and early April, or is this going to just kind of run its course for 4 or 5 weeks and then done?
Yeah, so I don't really know the answer to that. I would say that these things tend to run their course 4 to 6 weeks. Sometimes it goes out to 2 months. It's hard to know, but I wrote a paper showing that the seasons are shifting, where it's the first part of the winter is warmer and the latter part is colder. So I definitely believe there's a shifting of the season, and I would expect something similar this year as well.
Is that a decadal thing?
Well,
is
it's
it
over
sea
since the
ice
past.
related?
It's what I mean.
Is it related to the extent of sea ice in the Arctic regions, as far as providing a source for cold in that region?
Yes.
Or
Well, I mean, I do think it's related to the polar vortex. I mean, I think it's a combination of climate change and the behavior of the polar vortex. I do think it's really hard to get cold weather without these polar vortex disruptions, and there's more than one flavor of them. And in the absence of the polar vortex disruption, just climate change with a warmer world is going to give you warmer temperatures. Also, so the polar vortex disruptions are happening more frequently. Also, it tends to be warm ahead of these events also. So, and I wrote a blog about this.
I did read that, and it made perfect sense. It
Yeah,
makes
so
total sense.
people were complaining that winter's over, it's canceled, but I mean, it's two sides of the same coin. I mean, you get this kind of multi-week period of kind of bland winter weather, warm. It just that's what you would typically expect ahead of a polar vortex disruption. So we've gone through the warm period. It looks like it's about time we're going to get into the cold period. It should. I mean, again, I'm not guaranteeing anything.
Right. No. Understood.
Right. I mean, but basing on many past events, and seems to be a very impressive looking event. Sometimes, if it's really impressive in the stratosphere, it's not so impressive in the troposphere, and if it's really impressive in the stratosphere, no one's going to remember it. Maybe I'll remember it, but no one else is going to remember that we had this incredible polar vortex split that did all these amazing things, but it didn't produce any snow and barely produced any cold, and no one's going to care.
Exactly.
But
I
sometimes
appreciate that. So that's one worry I have. I mean, you want it impressive in the troposphere, you don't want it impressive in the stratosphere.
But you don't want to be too. You don't want to be
winter weather enthusiast.
You don't want to be too impressive. I mean, here in the New York area, as I said, we've had a paucity of snow since that storm in mid-November. Meanwhile, there are folks down in Virginia and North Carolina that have already been dumped on up to 20 inches in some cases. And it wouldn't be out of the question for this system on the weekend to dump again on them and possibly miss us because of the fact that the cold air that has dripping or oozed on down from Labrador and eastern Canada was a little bit too much for that snow or that storm to head northward.
I mean, for the Northeast, you want that high pressure to be over Quebec. Certainly with that storm, it was right over, New England. I mean, that's just too far. That Arctic high was just too far south to allow, a snowstorm here. So it was much better for the Carolinas into Virginia. I mean, this storm could be a repeat, and and that could be the path. I don't know. I really don't know. I mean, it's just something to think about. We'll see. I mean, eventually the pattern shifts. Even in 2014-15, we started out in Boston getting a lot of snow, but eventually that stopped and it shifted into actually the Canadian Maritimes. I remember how Nova Scotia, I think, started getting the storm. We were just missing them. They were too far east.
And as I recall,
so over time, I mean, I think the pattern, but over the next several weeks, it could be kind of these repetitive. We'll see. I mean, I could be completely off. I still think, though, I do think polar vortex splits are conducive to some big snowstorms, and so we'll see. I mean, it's certainly not a guarantee, and there've been splits that haven't been any big snowstorms, and there might be really massive snowstorm in a place that not very heavily populated, and so it's not really, people don't remember it as much, but I think something to watch. But it's not. It doesn't mean it has to happen within the next week. I mean, I think this is valid for February, maybe even into the first half of March. So.
All right. Well, I want to thank you very, very much for being on here. We have taken one of the things I love about having my own YouTube channel is that I can sit here, and Joe and I can sit here with you and discuss the polar vortex for 50 minutes and not have someone say, you need to do this in 30 seconds. And, you know, you need to rap, you need to throw to a commercial. So this is a wonderful outlet, and I know that my viewers that have been watching tonight, the comments that they've been leaving on the chat, you know, have kind of expressed a similar sentiment and have really enjoyed you being here. And of course, I want to just extend another invitation. Anytime you want to come on, just let me know. The door's open, and guests are welcome.
Have Dr. Cohen come on at the end of the winter season, and he can take a big red ribbon and put a big red ribbon around the winter, and then we could just summarize what happened.
I don't want to spike the football before I cross the goal line.
Right. On a side note, though, with regards to the snow weenies, and one of the things that I find frustrating is the hyperbole sometimes, you know, and it's not coming from here, and it doesn't come from us when we do our weather on a daily basis, but when it comes from elsewhere and you can't really control what the message is, I think the average person has gotten the idea that every little snowflake is the next apocalypse. And, you know, here we are in a stretch in our area where we haven't gotten much snow. And this stuff has happened before, and it's happened again. And it's hilarious because we go into the winter seasons, you see all this stuff. It's like, well, this will be the epic winter of the century. Those are the things you see in October and November. then in December, you see by about you get to December 10th or 11th, the winter is over. Posts begin,
Right.
And then January and February come, and you have winter, and then March comes, and everybody's standing around saying, well, how come it's still winter? And then April comes, and they're still saying in some places, how come it's still winter? I get very frustrated.
No,
because,
you're right.
I'm trying to keep it straight with delivering a message, and it gets always, it gets kind of pulled in different directions that's beyond your control.
And we've had 6 consecutive, here in New York City, the tri-state area, we've had 6 consecutive above normal snowy winters. And you know that eventually the odds are going to say, all right, this is the year that we get a little bit of a break in the pattern. This could be the winter that could be the break. And people are jumping off, they're going crazy because they're acting as if it's not snow.
It's weather.
They want snow.
Yeah, and I like to talk about, we're living in the golden age of Noreasters. I mean, it's never been this good. Certainly from New York to Boston, and maybe Philadelphia.
When we were kids, Doctor. We growing up in New York City in the 70s and the 80s.
And count them on our hand the number of times that we had.
Yeah, I mean,
we would dream about winters like we've had the last few years.
I grew up in the supposedly the much colder, snowier years of the 70s and the 80s, and I remember 3 big snowstorms in those 20 years. I mean, that's just 3. I mean, in 2014-15, I saw 4. In 1 year, I saw more than I saw in 2 decades.
I know, it is amazing.
So you were in New England, the Boston area, right?
Well, in 70s, I was in New York, in Brooklyn. I grew up in Brooklyn. I mean, so.
But I mean, in the 70s,
I'm sure there were more in Boston than.
But in the 70s and 80s, you were in Brooklyn, or you were in New England?
No, New York, Brooklyn, and Manhattan.
Okay, because I said if you were up in Boston during the 70s and 80s, you were probably screaming at your TV screen every time Don Kent was the Frank Field of Boston, and it's like, come on, I want snow up here, Don. It was the same thing down here. We were suffering.
I exceeded my time with Don Kent, but
Joe brought up the 6 out of 7 winters. One of the beauties about Central Park's data is that it does go back pretty far. It goes back to 1869, and that includes the 1880s. And one of the things, now I set the bar high, okay? So I went one day and just kind of added everything up and did all the averages and figured out that the long-term average for snow in Central Park in that whole stretch works out to about 28.6 or 28.7 inches. So if you use that as the average line, as it turns out, this 6 winters out of 7 is unprecedented. It's never happened. There's never been a 6 out of 7 stretch in New York City Central Park snowfall. In fact, it's hard. I think the most you could find is 4 out of 5, and you have to go back to the 1880s for that. So, like you said, this has been a golden age of nor'easters since 2000, and in terms of snowfall, just as well. So when it gets back to even reverting back to the mean, boy, these snow weenies are going to be lined up along the cliff, and they're going to be ready to jump with no parachutes. It's going to be painful to watch.
No, they're definitely spoiled. I mean, they don't know, but a lot of the people that are young enough, they don't know the difference. They've always grown up with these big storms, but I mean, the 70s were really cold. But I mean, if you take away 78, there was no really. I mean, the 79 was a decent storm, but.
We were talking about that last night. Those 3 weeks in February.
This winter, again, the two of us, we go way back. This winter reminds me a lot of the winter of 72, 73, where we had ample cold weather. But all of those storms, most of those storms passed underneath us. Washington, Baltimore, even down into the Carolinas, like we already have seen. We ended up with 2.8 inches or 3 inches of snow.
3 inches.
That's the record low. I mean, I remember that winter in Brooklyn. I mean, it was like it barely covered. I don't think it made up to the top of the curb, and that was it. So that was incredible. But yeah, it was in the Carolinas. Had a big snowstorm that winter.
Well. We've got a system coming for the weekend, and we're going to bury our heads in it to try to figure out how many flakes are going to make it up our way. Doesn't look like it's going to make it up to you. But thank you again. Thank you so much for being here. As I said, you always have an open invitation to come on.
All right, thank you.
And thank you for your time. Thank you so much.
Thank you, sir.
You're welcome. I love talking about this stuff.
As do we. All right, that was Dr. Judah Cohen. It was wonderful to have him on. He's great. He really puts puts a lot of this, gives us some perspective of how intricate, how complex the atmosphere is, and
Absolutely.
how things work. And you and I are not here flipping switches, making things happen.
Yeah. Well, as we always tell our own viewers, we're only the messenger. We're not the ones who are working. How many people have already come to you and said, Joe, you got to do your power, wave your arms, and keep that storm away on the weekend?
Right.
Or bring it up, depending upon.
I know, exactly. It's not like we can do this. Okay, so just really fast, because I'm hungry and I haven't had my dinner yet, and I think there's a cold bowl of soup out there waiting for me. Just going to real fast run through what's going on. You're certainly welcome to hang around and join me.
Are you inferring that I could get out of here if you want?
If you have a bowl of soup waiting for you, it's up to you. Whatever you want to do.
No, we could talk quickly about what's
All right,
going
so let me run through really fast. We'll run through the weather. Just I want to bring the GFS up again. Because I'm going to bring the surface map up for Europe. Then we're going to go and take a quick look at what's going on for us with this next weather system. And anyhow, let me run back here to the beginning. Make sure the screen is good. So you saw the upper air from earlier. We have this storm that came down from the North Sea, dropped down through Central Europe and Southern Europe. That's kind of played itself through. And we still see over time that the activity is in Central and Southern Europe. And then gradually, once that ridge breaks down, eventually some colder air starts to move down to areas further to the west, into England and Ireland. Now, how much remains to be seen. This is one model run. The model does have actually a pretty wrapped up storm there coming into France and Spain later in the period. But at least for now, it's going to take a little while longer for that ridge to break down in Western Europe. Now let's come back home, because I think the issues still remain the same with regards to this next system. We're trying to figure out, how much suppression. And, Joe, this time around, the high actually, Dr. Cohen mentioned how the storm back in December where the high was in New England, and you need it more up further north in Quebec. And this time around, it actually is further north, not that far further north, but further north. It eventually drops into northern New England. You kind of look at this going into Friday, Saturday, and it seems like it's coming right at us. But that high drop southeastward is telling us that that northern jet is going to be a problem. It may get in the way.
It may actually. It's not. It looks like there's actually a break off of the precipitation shield, that we get something Saturday night into early Sunday, possibly, or possibly it passes off to our south. But the main storm actually waits and moves on a track further to the south, and then out over the ocean during Sunday night and Monday. So it's kind of a weird situation. And what we noted earlier, Joe, is that the NAM, the North American model, had the snow coming up into our area as soon as Saturday evening. It was one of the few operational models that were doing that. But then the intermediate, the 18Z run of the NAM, intensified the cold air, the dry cold air, and now it looks like at least according to the new run, and we'll have that the 0Z NAM run when we come back on Facebook later on. But it looks like now the NAM is suggesting that cold, dry air is going to suppress that snow even for Saturday night and early Sunday. So,
and meanwhile, down in Virginia, in southwestern and western Virginia, the GFS, I'm pulling up their snow amounts. Didn't get a chance to really get into this too deeply, but it does at least imply that there could be some significant snowfalls as you go westward. Roanoke, Lynchburg, Charlottesville, even into western North Carolina. Actually, extends some of the snow down into interior South Carolina, and I think that's going to really depend on how ultimately this wave comes out, because there's that lead warm advection that moves in, and you can see it here on the GFS. It just kind of dries up,
right.
And I think that's that dry air.
I said two pieces.
And there's the second piece. Right. I think the wider view will probably show it a bit better. So here's the second piece, and that is something that will probably produce perhaps some significant snows down through Virginia and western North Carolina. And then I guess the question is, how far it's going to eventually run out to the northeast and deepen, but it looks like it stays far enough offshore where there's no impact much further north than, say, central and southern New Jersey. But we'll have to deal with that with the next run. And the one last thing I want to do, and then we're going to say goodbye because my stomach is screaming.
I've got to go.
You go.
I go.
I'll deal with this. But when we look at the overall upper air in the long range, and it's been pretty much in every run, we are seeing the strengthening of the pattern in cross Canada, favoring cold air intrusions coming down over time and getting colder and colder, each shot getting a little bit more impressive than the one after it. So to me it looks like this whole event that has transpired is, it takes about, if there's a 2-week lag, takes us to the middle of January. Then we start to get to the latter part of the month. We're starting to see significant changes in the upper air across North America, as well as in the Pacific and on the Atlantic side. So I think for you winter weather and snow lovers, you're going to have your opportunities. We don't know, ultimately it's where do the troughs and ridges set up with each event. So it's no guarantee. There's nothing in the rule book that says it can't be cold and dry, as both Joe Rao and Dr. Cohen pointed out a bit earlier. So we're going to leave it here at this point. But what Joe and I will do is that we can pick up on the short-range issues on our Facebook show tonight. It's on my Facebook page, Meteorologist Joe Cioffi, and that will be probably at about 9:15, 9:20 Eastern time. So join us then, and we will get into the local stuff. And then I will upload that to the YouTube library around midnight. If I should be able to do it, so I'll upload it around midnight, and then you can take a look at that, or just wait till tomorrow morning, and you could watch it there. Want to thank all of you for being on, and I hope you enjoyed all of this today with getting Dr. Cohen on. That is, as I said earlier, having your own YouTube channel is a wonderful thing because you're the producer, you make all the decisions, you decide how long someone can be on, and if you want to have a show talking about the polar vortex for over an hour, you can do it because there's nobody around to tell you otherwise. I want to thank, by the way, David Schlotthauer for hitting Super Chat tonight. Thank you very much. And One Man's Opinion 1, thank you very much. That gets me a cigar, and I really appreciate it. Thank you so much for hitting Super Chat tonight. Let me also just really fast, for those of you who are new, so I hope you like what you see. We do weather here on my YouTube channel every night. At least once a day we live stream. And if you are into weather and you want a more extended weather experience, you can jump on my weather platform that I have on Patreon. And let me just give you the link. Somebody looking for me, Joseph? Came
No.
back to, oh, you came back to hang.
Yeah.
Oh, okay, good. Well, I'm just saying goodbye, so we can say goodbye together.
Okay.
So, for those of you who are interested, this is a subscription site. It's just $2 a month. Gets you lots and lots of coverage, private live streams. You can message me at any time. I'll respond in a timely fashion, and I'm even doing some, weather class exercises with the Patreon members, getting them used to. What it's like to make a forecast, and getting used to all the upper air maps and what they mean and how to use them. So you might enjoy that. So there's the link for that. So do consider it. And some parting thoughts, Mr. Rao?
Well, we'll see what happens this weekend.
Yeah.
And
I said we're going to cover all of that when we do the Facebook show tonight.
yeah, and again, we'll have the now the NAM tonight. The 84-hour will go how far out now? That would take us into
Was it 12Z
Saturday,
Sunday?
Saturday evening, Sunday morning.
Sunday morning.
All right.
Yeah, 12Z
Well,
Sunday.
So that should make for an interesting round to see what the new data is. The very latest of the operational models that are available during our Facebook page. I'm glad you arranged to have that happen.
Yes. What, the Dr. Cohen having them on, or having the Facebook page?
No, well, both. Both.
Yeah. Now, yes, I just told everybody, since we didn't really have a lot of time to get into all the stuff that's going on for the East and around the U.S., we're going to do that on the Facebook show tonight at 9:15. So I got that soup waiting for me.
Okay.
We'll see you later, guys. Thanks everybody for being here. Good night.
Soup's on.
Yeah.